In this tutorial, we're going to be talking about incandescent lamp or a filament lamp. A filament lamp is, as you see in this picture, has different components. It first has the glass bulb, the filament, the metallic base, and here we have the insulator. As the electrons move through the filament, they are constantly bumping into the atoms that make up the filament. The energy of each impact vibrates an atom. In other words, the current heats the atoms up. These are the atoms of the filament. So we say that heat energy is produced. As the collisions increase, more atom vibrations, more heat energy is produced. So the filament is heated. It transforms electric energy into light and heat energies. Now let's see a current potential difference graph for this filament lamp. The line curves away from the y-axis so the current is not directly proportional to the potential difference. The filament lamp is a non-ohmic conductor. The equation of the resistance of an appliance is R equals V over I. Here the resistance increases as the current increases, so the resistance of a filament lamp increases as the filament temperature increases. The atoms in the metal filament vibrate more as the temperature increases, so they resist the passage of electrons through the filament more. The resistance of any metal increases as its temperature increases. Reversing the potential difference reverses the current and makes no difference to the shape of the curve. The resistance is the same for the same current regardless of its direction. When the filament light bulb fails, it usually happens when you switch it on because resistance is low and the bulb is off. A big current passing through it when you switch it on. If the current is too big, it burns the filament out.